Bismillahirrahmanirrahim. Assalamu alaikum. This is the fourth lecture of physics for class 9th. Physical quantities and measurement. Before starting today's lecture, let's have a recap of previous lecture, lecture number 3, in which we studied about the mass measuring instrument, the beam balance, the electronic balance, and the physical balance. We studied about their working as well. The next is time measuring instrument, the stopwatch. We studied about two types of stopwatches, analog and digital. The last one is the volume measuring instrument, the measuring cylinder, in which we studied about the methods of measuring the volume of the liquid as well as the irregular shaped objects. In this lecture, we will study about significant figures. Why? Significant figures are an important part of scientific and mathematical calculations and deals with the accuracy and precision of numbers. It is important to estimate uncertainty in the final result, and this is where significant figures become very important. Greater number of significant figures means the measuring tool is more precise. Significant figures. The value of physical quantity is expressed by a number followed by some suitable unit. Every measurement of a quantity is an attempt to find its true value. The accuracy in the measuring a physical quantity depends upon various factors. Number 1, the quality of measuring instrument, the skill of the observer, the number of observations made. For example, a student measures the length of a book as 18 cm using a measuring tape. The numbers of significant figures in his or her measured value are 2. The left digit 1 is the accurately known digit, while the digit 8 is the doubtful digit for which the students may not be sure. Another student measures the same book using a ruler and claims its length to be 18.4 cm. In this case, all the three figures are significant. The two left digits 1 and 8 are accurately known digits. Next digit 4 is the doubtful digit for which the students may not be sure. A third students record the length of a book as 18.425 cm. Interestingly, the measurement is made using the same ruler. The number of significant figures is again 3. Consisting of two accurately known digits 1 and 8 and the first doubtful digit 4. The digits 2 and 5 are not significant. It is because the reading of these last digits cannot be justified using a ruler. Measurement up to the third or even second decimal place is beyond the limit of the measuring instrument. Rules to identify significant figures. Following are the rules helpful in identifying the significant figures. Number 1, non-zero digits are always significant. Number 2, zeros between two significant figures are also significant. 3, final or ending zeros on the right in the decimal fraction are significant. Number 4, zeros written on the left side of the decimal point for the purpose of spacing the decimal point are not significant. Number 5, the whole numbers that end in one or more zeros without a decimal point, these zeros may or may not be significant. In such cases, it is not clear which zeros serve to locate the position value and which are actually part of the measurement. In such a case, express the quantity using scientific notation to find the significant zero. Now I am going to explain you the rules to find the significant digits in a measurement with the help of the examples. Rule number 1 is digits other than 0 are always significant. For example, 27 has 2 significant digits and 275 has 3 significant digits. Rule number 2 is zeros between significant digits are also significant. For example, 2705 has 4 significant figures and you can see that there is a zero between the digits. Rule number 3 is final zero or zeros after decimal are significant. In the example, we are having 275.00 has 5 significant digits. As you can see, there are 2 zeros after the decimal. For zeros used to spacing or for the spacing, the decimal point are not significant. Here, zeros are placeholders only. These zeros are placeholder and has significant digits 1 only. So in this case, it's better to write them in the form of scientific notation. And how we can write them in the form of scientific notation? 3.0 into 10 raised to the power 2. So minus 2. And here we are having only one significant digit. In this example, 0.027, we have got two significant digits. These zeros are also the placeholders, and we can write them like 2.7 into the 10 raised to the power minus 2. So that is how we can find out the significant digits in any measurement. Let's have a recap of all we have studied in this lecture. First, about the significant figures. In any measurement, all accurately known digits and the first doubtful digit is known as significant digit or significant figure. Now we will discuss about the rules with the help of some examples. Here we have got the table and we are having some numbers here, and then we will find out the number of significant figures out of these numbers. Rule number 1. Any non-zero number are significant figures. In the table you can see 17. 17 means two significant digits, and in the next example it's 5631.54. All will be considered to be the significant digits. So what do you think? How many significant figures are there? Yes, 6. Rule number 2. Any zeros between the two non-zeros are significant figures. In this example 101, we are having 3 significant digits, and in the next one we are having five zeros between 2 and 9. So the total number of significant figures will be 7, as all the numbers will be considered to be significant digits. Rule number 3. Any zeros before non-zeros numbers are not significant digits. It means that the 0.5 is having only one significant digit, as this is only a placeholder. And in the next example we are having 0.00013505. In this example, these three zeros are also the placeholders. We will not consider them significant, so the total number of significant figures in this value is 4. Next rule is any zeros after non-zeros in a number with decimal point are significant figures. Means that 500.0s, all these digits will be considered to be significant. So the total number of significant digits are 4. In the next one, we are having total number of significant figures. How many? 3. These two will be considered to be placeholders. In this, again, these two will be the placeholders, and the total number of significant figures are 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that is how we can find out the number of significant figures in any measurement. I hope you have understood. Dear students, this is the end of the chapter number 1, Physical Quantities and Measurement. I hope you understood each and every topic that I have taught you, and you will learn it as well. Thank you so much.